Hello 12th standard students, welcome back to chapter 4 inverse trigonometric functions. Today we are going to see the remaining three functions. We have seen sine, cos and tan. So we are going to see the inverse functions of sine, cos and tan today for that graph and its inverse graph. Okay. So first is going to be a very short video for you. Just I am going to go through the points only. You are not going to go into detail. Okay. The cosecant function and the inverse cosecant function. So what is the cosecant function? Is an odd function with a period 2 pi. Okay. So it has a period of 2 pi and I have given you the graph also. So domain is R other than n pi and belonging to Z, and the range is minus infinity comma minus 1 union 1 comma infinity. Okay. Here they are given the graph for you, and a continuous graph is also given, and there is a line in between. Okay, that you can understand easily. And the inverse cosecant function is going to be just opposite of this, minus infinity minus 1 union 1 comma infinity to minus pi by 2 0 union 0 pi by 2. Okay, is defined as cosecant inverse of x if and only if cosecant y equal to x and y belongs to this range. Okay, the inverse cosecant function domain is R other than minus 1 1 and the range is minus pi by 2 other than 0. Okay, so here is the graph for you in detail given for you. Cosecant, this is cosecant graph and this is cosecant inverse graph. Okay, so you can see here it is x-axis you have got pi by 2 and minus pi by 2, whereas in the y-axis you have got pi by 2 and minus. So just the opposite of cosecant and cosecant inverse. Next you go into the secant inverse, secant and secant inverse. Here also secant is nothing but 1 by cos. Therefore the domain of the function y equal to secant x is going to be R other than 2n plus 1 pi by 2 n belonging to Z as minus 1 less than or equal to cos x less than or equal to 1, and y equal to secant x does not take values in minus 1 and 1. Okay, it's understood. And therefore period is with period 2 pi, and this is an even function, secant function. So here is the detailed graph for y equal to minus 1 and y equal to 1. It does not touch the x-axis. Okay, and they are given the continuous graph for up to minus 2 pi 4 pi they are given. Okay, what about inverse? Inverse is going to be just opposite. Range is domain is R other than minus 1 1 to 0 comma pi other than pi by 2 is defined as secant inverse of x, where y belongs to 0 comma pi other than pi by 2. And here is the secant graph. Here you got the secant inverse graph. Okay, cotangent function and the inverse cotangent function. Cot function, cot is nothing but 1 by tan. So it is defined as domain is going to be R other than n is at n belonging to Z, and its range is going to be minus infinity infinity. And tan x, the cotangent function, is an odd function with a period of pi. Okay, so this is odd function with period pi. Okay, the cotangent function is continuous on the set 0 comma 2 pi other than pi. So graph of first tangent cot x. Here they see the cotangent function falls from infinity to 0 for x belonging to 0 to pi by 2, and falls from 0 to minus infinity for x belonging to pi by 2 comma pi. Okay, here they are given the first one, and similarly from infinity to 0 for x. Okay, so here first graph cot x and second graph they are given from 3 pi minus 3 pi to 3 pi. So the graph of y equal to cot x is x belonging to 0 comma 2 pi other than pi is shown in the figure 1. We take this as figure 1. Figure 1. Okay, the same segment of the graph of cotangent for 0 to pi other than pi is repeated for 2 pi 4 pi other than 3 pi 4 pi 6 pi other than. So in the middle, whatever you get in the middle or the even numbers, here 4 and 6, in between 5. So along 5 pi you will not have the graph. Okay, it does not touch. That is understood because it is 1 by tan. Okay, so it's understood. With the domain R other than n pi, where n belongs to Z, is shown in the second figure. Inverse of cotangent function, it's going to be the opposite. Cot inverse is the domain is minus infinity to 0 comma pi, and define if and only if cot y equal to x, where y belongs to 0 comma pi. So I have compared both. This is the cot x graph and this is cot inverse graph. So the main for this video is to give you this principal values. So you can see here. So here it is sine, principal domain is minus pi by 2 to minus 1 comma 1 is the range, whereas for sine inverse it's just the opposite. The range has become the domain and domain has become the range. Okay, so I have given for all the 6 functions. Sine, it's from your book, textbook. This, if you remember, it will be easy for you to do all type of problem. It can be sine, cosine, tan, cosecant, secant or cot. or sine inverse, cos inverse, tan inverse, cosecant inverse, secant inverse, or whatever it is. So this table, if you remember, any one, just for sine, cosine, tan, cosecant, secant and cotangent, it's just going to be a opposite. So just if you remember the principal domain and range for the 6 functions, sine, cosine, tan, and a cosecant. Cosine is nothing but cos, okay, secant and then cot. Of these 6, if you remember, the inverse is going to be just opposite. Whatever is in the range is coming into your domain, okay. So this tabular column is very, very important, and you remember this 6 alone, it will be easy for you to solve all the 5 chapters problems, okay. Thank you.